Hi class, my name is Sandra Jones and I teach software engineering at Kennesaw State University. If you're interested in computers, one thing that you need to know is that they are not smart devices. In fact, everything that we do on a computer is made possible because a programmer has written a set of instructions and uploaded those to the machine to make things happen. Anything you do on a computer, from word processing to using a browser to using social media, all of that is made possible because a programmer has written the instructions to make that happen for you. We'll talk about designing and writing those programs in later lessons, but today I want to talk to you about how a computer understands what we tell it to do. Computers do not speak English, so when we write computer code, it has to be translated into something that the computer understands, which is ones and zeros. We'll have a brief introduction over the concept with a PowerPoint slide presentation, and then I'll walk you through an activity in which you'll encode words and take your classmates' encoded words and decode those, and we'll see how that happens using Ascii.
Now we'll spend a few minutes discussing Ascii in more detail and how it fits into computing. As I mentioned earlier, your computer does not understand English, so we have to translate our instructions into what the computer understands. Computers speak in ones and zeros. In fact, in the early days of computing, programmers coded machines literally using ones and zeros. This made programming a tedious and time-consuming task. Fortunately, programming has progressed quite a bit, and we now have much more advanced tools called integrated development environments that allow us to write code that closely resembles natural language, and the translation to ones and zeros is done for us. Think of it this way. You wouldn't pass up the opportunity to travel to a country that doesn't speak your native tongue, but once you were there, you would have to figure out how to speak their language in order to communicate during your visit. ASCII is an acronym for American Standard Code for Information Interchange. It was originally based on the English alphabet, and it encodes 128 specified characters into 7-bit binary integers, as shown by the ASCII chart to the right. You will find the same chart with only uppercase letters in the kit documentation. In addition to uppercase letters, ASCII contains representations for the numbers 0 through 9, lowercase letters A to Z, and basic punctuation symbols. There are other encoding systems that make even more characters available, including what is known as extended ASCII, which is represented with 8 bits. Every time you press a key on your keyboard, a numerical representation of that number is transmitted to the computer. The ASCII character set uses a series of ones and zeros to represent all uppercase letters in the English alphabet, as shown on the slide. At this point, you may be wondering why ones and zeros? This is literally because a computer understands two states, on and off. If you've ever wondered why the power buttons look the way they do, here's your answer. It's a combination of both states. The following is the ASCII representation of the most commonly used output for new programming students. Pause the slideshow here and see if you can decode it. Examine the letters that are repeated on both lines to make your work go quickly. Did you get it? If you guessed hello world, that's absolutely correct. Now let's move along to the learning activity and have some fun encoding and decoding words. Enjoy yourselves.
For this activity, we recommend that you have your students work with a partner to encode a word. You can use a given set of vocabulary words from other lessons, or you can ask each set of students to choose their own word to encode. Each set of students will need a printout of the Ascii table for uppercase letters that is provided in the kit documentation, and a way to represent ones and zeros as mentioned in our lesson. In our case, we have provided each set of students a total of 150 1x1 Lego blocks, half of which are gray to represent 0, and the other half to represent 1, which are orange. If Lego are cost prohibitive, you can always cut out small squares of 2 different colors, or even use graph paper or notebook paper to encode your words. To begin the activity, each set of students will choose a word to encode. For this demonstration, I will use the word hello. I start by looking up the letter H in the table and see that the letter H is represented by 100, 1000. So if you'll recall, we're using orange blocks to represent ones and gray blocks to represent zeros. So what I want to do is build a string of these Lego to represent this number combination. So I start with an orange, and then I add 2 zeros, add another orange, and then 3 more zeros. So now I have a visual representation of how the uppercase letter H is represented using Ascii. For this demonstration, I just linked together each 1x1 block, and when you're done, you can either link all of the letters on if your word is not very long, or you can just lay them out in the proper order to pass to the other students for decoding. For this example, I've gone ahead and created the rest of the word and attached it to a base. If you do have the benefit of having Lego bases or Lego tape, it will be a nice addition to organize your work, and it also makes it a little easier to decode, but these bases and tape are usually pretty expensive, so if that's problematic, again, you can just link all of the letters end to end just like that. And the first thing that the decoding students would do is take them apart and lay them out for decoding. So for the last part of the activity, what we're going to do is trade our encoded word with another set of students so that they can decode the word. And the way we're going to do this is, again, I've gone ahead and built the rest of the word hello, shown here, linked end to end. If you use this approach, the first thing the decoding team will want to do is separate this at every 7th and 8th block. As shown here. And so then we have the representation of our encoded word hello. So for the sake of this demonstration, in a normal classroom setting, if you use this approach, you would just start and decode these letters. But for this demonstration, I'm going to use the word that I built on the block that I had available. So what your students will do is start at the top and decode each letter. So again, oranges represent ones, gray represents 0. So this first letter would be 1, 0, 0, 1, 0, 0, 0. And each time we discover the pattern of ones and zeros that correspond to a letter, we'll want to find that code on our original table that we used to encode our word, and we see that that is the representation for H. And we'll want to go ahead and write the letter H here. So we'll step through each letter that's here encoded to uncover the word that we've encoded in Ascii. You see that here are all of my codes and the corresponding letter.